Hey guys, so we are finally going to get started with Earth science, which is my favorite topic. And we're going to start out with Earth's interior or Earth's layers. I really like this picture because it shows all the layers, kind of like if we were to open up Earth and see what it looks like on the inside. Here I've got a link to a Brain Pop video that we'll be watching in class that talks about the layers. I'm not sure if you can watch this because you might need to be a subscriber, which is what the school pays for. Here's a quick overview of the different layers that we're talking about and what they look like. So we've got four basic layers: the crust, the mantle, the outer core, and the inner core. And we're going to get into a little bit more detail about what is in each layer and how big each layer is. But before we do that, I wanted to talk a little bit about my experience on the JOIDES resolution, which I've talked to you guys about before. I talked about this before. So this is a deep sea drilling ship, and the expedition that I was on, we were actually starting off a drill hole that is eventually going to get to the mantle. So we've never dug far enough. Humans have never dug far enough to actually get to the mantle, but that's one of the objectives of some of the scientists that I was on board with. So this is what it looks like when the JOIDES resolution is actually doing its drilling. And so on the expedition that I was on, about 700 meters is how much water we went through, and then of actual drilling, I think it was a little over, if I remember correctly, it was about 800 meters. So still a long ways off, but it's the first of 3 planned expeditions to eventually get to the mantle. So this is just kind of a clip from the BBC, and they were doing an article about the expedition that I was on. And on the left-hand side, there's a picture here of basically what they're drilling through. So this is the area that they're trying to get to right here between the crust and the upper mantle, this area right here. And these are just some of the rocks. So this is a rock called gabbro. This is what makes up the crust or the lithosphere that we were drilling through. So all the rock that we collected while I was on board looked like this. And eventually we want to get to this. This is a rock called peridotite, and this is actual mantle rock. And the way that we know that is because sometimes volcanoes will actually spit this stuff out, and this black stuff that you see here, this is regular lava called basalt. And so that's just regular magma, right, that hardens. But this green stuff, this is something different. This is actually from the mantle. And so we know that that is way down deep because these volcanoes spit it out, and we can actually find some of it that has gotten pushed up by tectonic activity. And so we know that the mantle is made up of this green stuff called peridotite, which actually is used to make gemstones, which is called peridot. If you were born in August, I believe, this is the gemstone for your birth month. And then this area is where those layers actually mix. Let me erase my circles. And they mix with water. And what's really cool about that, you can actually see how it's a little green here from the olivine that makes the peridotite green. When we have water enter this rock, there's the possibility of life, which is really, really cool. And I've talked to you guys about Ginny and Jason, who are microbiologists that worked on the ship with me, and that's what they're doing. They're looking for life in this area right here, in this rock. So here's a picture of Ginny. She's cracking open some of that rock, and she's going to scrape out the inside and see what grows from there, see what's living in there, and identify it. And here's me on the ship. So this is that rock that I was talking about, and you can see some more of it here in the background. This is gabbro. This is actual crust. This is lithosphere from Earth. And this is, of course, oceanic crust because we were drilling in the ocean. And here's Slow-Mo. This is when Slow-Mo got his start. And so Slow-Mo is actually working with a geologist from Japan named Tomo, and they're looking at some of the gabbro that we collected. So let's get to the notes. What is inside the Earth? So here's just a general idea so you can label your notes really quick. Remember to pause this anytime if you need to copy this down so that you can, so it can go a little slower for you. But what I want to point out here is the big difference in sizes. Of course, this is not to scale, but it kind of sort of is. The crust is very, very thin. We've got the thickest layer is going to be the mantle, and then the outer core, and then the inner core is finally on the very inside. So we're going to be writing on the left-hand side. I blocked this out because I didn't like what this company had written. So we're going to write something a little bit different from what they had written down. So here we go, the crust. It's really rigid and thin. If we were to split up all the layers of Earth and, you know, by volume, percentage wise, the crust is only 1% of Earth. And so the oceanic crust is obviously going to be thinner, which is why it's easier to get to the mantle through there. And the continental crust is going to be a lot thicker. So we're talking 30 kilometers to 100 kilometers thick of continental crust on average, right? And then only about 5 kilometers thick of oceanic crust on average, of course. And the big difference here, right, between the 30 and the 100 kilometers is mountains. So if we're trying to dig to the mantle on Mount Everest, that would not be very smart, right? Because it would be way thicker there than it would be in other locations. So I wanted to pause for a second and talk about the basically the parts of the crust called the lithosphere and the asthenosphere. And so the lithosphere is the very top part of the crust, and so it's basically the very part that we touch or directly under the soil that we walk on. And the way that I remember this is I think LA, like Los Angeles, the lithosphere is on top, and then I have the asthenosphere directly under that. So here's some pictures of the asthenosphere. An easy way, again, to remember this is just remember the LA. Lithosphere is on top of the asthenosphere. So here we've got the lithosphere over here, and then the asthenosphere underneath here. And then on this picture over here, we've got the lithosphere here and the asthenosphere here underneath that. Basically, it's kind of like where the mantle and the crust meet, right? There's where the asthenosphere is. So the mantle, our next layer, it contains more iron, magnesium, and calcium than the crust, and it is a lot hotter and denser. And it makes up 83% of Earth. So that's why I was saying that the mantle is the thickest layer. It's also the biggest in terms of volume of all of the layers. And the cool thing about the mantle is it's got these awesome convection currents here. And these convection currents move because of density. So here we've got a really hot outer core and inner core. So this is super duper hot because of pressure, right? Everything's pushing down on it. So we've got lots of pressure here. And when stuff is hot, it's less dense, so it floats up. So the core here, the outer core and the inner core, is actually heating the magma that we have in the mantle. And this is very, don't think of it as a fluid type of magma. It's very kind of a mixture of solid and liquid. And we have it float up because it's hot. When it gets over here close to the crust, it's not as close to the core, so it cools down and it can't come down back down the same way, right? Like it's like a train. It keeps just coming up and coming up. And then so it creates this convection current and has to come down because it's more dense now, it's a little cooler. And so that's what creates these convection currents. And so we have this one moving in this direction, we have this one moving in this direction. And so what happens here is it's kind of like if you take a pool floaty and you put it in a river, it's going to go, the floaty is going to go in the direction of the water, right? So that's what's going to happen to the layers of lithosphere on top of it. The crust is actually going to separate here. And if I have two that are coming together, like if you see right here, these two are coming together, they're going to crash into each other. And we'll talk about that a little bit more in the next set of notes. And so then we've got the outer core is the next deepest layer, and we've got liquid nickel and iron here. Together, the inner and the outer core are going to make up 16% of the volume of Earth. And then the inner core is solid, mostly because of all the pressure, and it's also made of lots of iron and nickel.